There isn't much that's new for our math skills today, but just to really go over cross multiplication, that's the purpose of today. So if you have two relationships that are proportional, like in Charles' law or Gay-Lussac's law, because we have temperature, which is proportional to both volume for Charles' law or for pressure for Gay-Lussac's law, the equations are set up like proportion, or kind of in this similar manner that I just circled. There's as fractions. And so the best way to solve proportions is to cross multiply. And so what you do with cross multiplication is you take the two that are diagonal from each other and you multiply them and you set them equal to the other diagonal. So you kind of make a cross or an X, and then you end up with two different multiplication problems that are now equal to each other. And that helps just simplify your solving process. So everything on this worksheet is the same as what we learned on Monday, just a little bit more practice with doing the cross multiplication for the two that involve proportion setups. So that would be our answer for number 1. Which gas law equations will use cross multiplication when solving? That would be, I just said it, Charles' law and Gay-Lussac's law. And again, that's because they're set up with proportions when you solve them. So all of the problems, I think there's just one that is not, there's one in here that is Boyle's law, and you won't need proportions, but the rest you will. So let's do the first one together, and then I'll let you loose on the rest, because the process, like I said, is exactly the same as what we learned on Monday. So it says a 3.5 liter gas increases its temperature from 115 Kelvin to 295 Kelvin. What is its new volume? So first, let's find our variables. I like to circle them and just label what they are. So that's my first temperature, my second temperature, and I am finding V2. So that's my find. So if I have volumes and temperatures, this would be my Charles' law relationship. And my description, this is where I'm going to actually think about their relationship, kind of all the stuff we did last week. So our temperature looks like it's increasing. Therefore, what will happen to the volume? According to Charles' law, it should increase. So temperature increases, volume increases. We are now adding in the equation, volume 1, temperature 1, volume 2, temperature 2. Because they are proportional, we can set up this equation. And now you just plug and chug using cross multiplication. So our V1 we said is 3.5. T1 is 115. It's already in Kelvin, so we do not need to convert. We don't know V2, and our temperature 2 is 295. Now we will cross multiply. Plug in 3.5 times 295, and you'll get 1032.5. Now it's really simple to solve. To get our variable by itself, we're just going to divide. And we've got our answer. So divide those two values, and you will get that the second volume will be, straight from the calculator, 8.9782, yada, yada, yada. However, for significant figures, it looks like our least amount is 2 significant figures. So I'm going to round this to 9.0 liters. And there is our volume 2 after increasing the temperature. And our numbers agree with our description that as the temperature increased, but also the volume increased.